remember this scene. River flows have become mere trickles. Lakes have turned into lowlands, and reservoirs are nearly emptied and have reached new lows. Government agencies are busy with transferring, distributing, and rationing water. The general public, however, is busy storing and buying water. All of a sudden, water has become the most treasured resource. This is the situation of the major drought which Taiwan experienced in the spring of 2002. It was like an alarm reminding us that water resources are limited, and Taiwan is a country which is rather lacking in water resources. Taiwan is surrounded by sea. It rains in each of the 4 seasons. The average annual rainfall reaches 2,515 millimeters, which is 2.6 times the global average of 973 millimeters. However, if the comparison is made on the basis of annual average per capita, because of dense population, it amounts to only 4,113 cubic meters, which is less than 1/7 of the global average, and even less than Australia, the continent with the lowest annual precipitation. Therefore, Taiwan is a region with a shortage of water resources. Taiwan has plenty of rainfall, so why is there a water shortage? The root of the problem lies in its natural environment. From a geographical consideration, Taiwan is a small land area, but there are numerous high mountains and steep hills. The topography is long from north to south and narrow in east to west directions. As a result, each river has the characteristics of being short and steep. Once it rains in the mountainous regions, rapid water flows into the sea quickly. May to October of each year is the wet season in Taiwan, with monsoons and typhoons the major sources of precipitation. November to April is the dry season. During this period, southern Taiwan rarely rains, where the ratio of rainfall of wet to dry season is about 9:1. In northern Taiwan, due to the effect of the northeastern monsoon, the situation is better. The wet-dry ratio is 6:4. In central and eastern Taiwan, it is 7:3. In addition to uneven temporal distribution, spatial variation of precipitation is also large. Annual precipitation can reach as much as 5,000 millimeters in locations, but the lowest is only 1,250. Due to the hydrological cycle, there is also a very large variation in annual rainfall. Data from the last 50 years show that the maximum annual rainfall was 3,250 millimeters, while the minimum was 1,600. The difference between high and low is quite substantial. In Taiwan, there exists a major correlation between the amount of rainfall and topography. It is most important as whether the rainfall can become usable water resources. One can classify a rainfall catchment area in accordance with the quality of water and the convenience of utilizing the water into 3 categories, class 1, 2, and 3. The catchment area in valleys upstream from plains is in natural forestry land where there are mountain ranges and the environment is unpolluted. The rainfall collects in river valleys or seeps underground and then seeps out as continuous river flow. It has good water quality and is easily diverted. Such a catchment area is a Class 1 water source region. Downstream from river valleys, the ground on both sides of a river may be mild in slope, may be a plateau or agricultural flat land. This is a Class 2 water source region. From the point of view of a river, it is approximately the middle to downstream region or the catchment area of a river originated from a plain. Rainfall in this region, in addition to becoming effective rainfall for use by farms, a good portion seeps into the earth, becoming groundwater, or drains into rivers, becoming river flow. Being located on both shores of the middle to downstream reach of a river, the amount of water is small and scattered. At the same time, they are subjected to certain degrees of contamination, and the opportunity of using the rainfall is less. In coastal areas not far from rivers flowing into the sea, or areas where there are densely populated cities, rainwater often is directly discharged. Utilization is low, or because of pollution, it cannot be used. This is the Class 3 water source region. From the point of view of water resources, the one that is worthy of the most attention is the Class 1 water source region. Rivers with major water resources in Taiwan include Lanyang, Danshui, Touqian, Zonggang, Holong, Da'an, Dajia, Wu, Qiushui, Bazhang, Jishui, Congwen, Gaoping, Sichong, Beinan, Shouguluan, and Hualien River. The total area of Class 1 water source region is about 19,400 square kilometers, which is about 54% of the total area in Taiwan. The annual rainfall is 55.2 billion cubic meters, or about 61% of the total rainfall of 90.5 billion cubic meters. Let's look into the situation of water resources utilization in Taiwan. Let's consider some data. Of the total precipitation of about 90.5 billion cubic meters each year, 22 billion cubic meters evaporate. 4 billion cubic meters seep underground. The remaining 64.5 billion cubic meters flow into rivers. Among them, because of temporal and spatial uneven distribution and excessive concentration at times, 52.75 billion cubic meters are discharged into the sea without being utilized. That is to say, only about 11.75 billion cubic meters of river flow are utilized annually. This, plus the groundwater utilization of 6.28 billion cubic meters, the total volume is 18.03 billion cubic meters, amounting to about 20% of the total rainfall. However, if one considers that the sum of Class 1 water source region of 55.2 billion cubic meters of rainfall plus a groundwater surcharge of 4 billion cubic meters in Class 2 water source regions is 59.2 billion cubic meters, the utilization is about 30%, which is quite high. Of the total annual utilization of 18.03 billion cubic meters in Taiwan, 75% are for agriculture, 16% for domestic consumption, and only 9% for industrial use. The productivity of agricultural water consumption is low. After joining the WTO, the total agricultural use of 13.5 billion cubic meters will be reduced each year, and the industrial water use will increase, so the demand for large quantities of industrial water and for a stable water supply will increase, especially for the rapidly developing high-tech industries. To develop Taiwan into a green Silicon Island, water is one resource that we cannot face any shortage. As for water for domestic consumption, among the 2.9 billion cubic meters, 83% are surface water and 17% are groundwater. The surface water includes that of river runoff and reservoir storage. Among them, 12% are river runoff and 71% are from reservoirs. It is thus apparent that water for domestic consumption relies heavily on reservoirs. Considering water sources, of the 18.03 billion cubic meters, the amount of surface water is 11.75 billion, or 65%, and groundwater is 6.28 billion, or 35%. This shows that the use of groundwater plays a very significant role in Taiwan. The annual groundwater surcharge in Taiwan is only 4.0 billion cubic meters, but the utilization is as high as 6.28 billion cubic meters. That is, the overpumping is 2.28 billion cubic meters. This occurs mostly in the western coastal zones. Overpumping of groundwater causes the groundwater table to drop continuously. In addition to saltwater intrusion and affecting land utilization because of saline soil, it also causes irrecoverable land subsidence and induces problems such as floodwater drainage and severely damages and threatens the life quality and wealth of the general public. In Taiwan, regions with the above-mentioned problems include coastal zones of Pingdong, Kaohsiung, Tainan, Jiayi, Yunlin, Zhanghua, and Yilan, with a total area reaching 2,400 square kilometers. If Taiwan is to avoid the consequence of overpumping groundwater, the quantity of groundwater utilization should be controlled to retain the principle of balancing between withdrawn and surcharge. That is to say, the annual utilization should not be higher than the surcharge of 4 billion cubic meters. The other important topic on Taiwan water resources is the preservation and enhancing of water source regions. Presently, Taiwan has 40 to 50 reservoirs. Almost exclusively, they are located in Class 1 water source regions. Due to topographic limitation, their sizes are not large. There are 7 reservoirs with a capacity in excess of 100 million cubic meters. The largest one is the Congwen Reservoir. Presently, its effective storage is about 600 million cubic meters. Owing to small storage capacity, the ability to regulate and storage is limited. This, plus erosion and siltation upstream, causes a more tense and insufficient condition on the limited amount of water. Taiwan is situated at the junction and collusion point of the Euro-Asian continental plate and Philippine plate. The land is very steep. In addition, due to weak geography, heavy concentration of rainfall in summer seasons, and overdevelopment of the drainage basin means surface erosion is very severe. This results in reservoir siltation and affects reservoir operation and life. Among reservoirs in Taiwan, the one that is most severely silted is the Agongdian Reservoir, where more than 70% of the original capacity of over 20 million cubic meters has been silted and has degraded its function for water supply and flood control. Presently, it is being drained and undergoing a large-scale desilting work. Dewatering for dredging is the most economical and effective method of desilting a reservoir. However, under the present situation, when all reservoirs are bearing a heavy burden of supplying water, it is questionable that there could be an opportunity to empty them. Without emptying, generally, dredging of mud is the approach. However, the efficiency is low, the water consumption is high, and so is the cost, and the scheme does not receive general consensus. To reduce reservoir siltation, desilting is an unpleasant choice. The root solution would be to cut off silt from the source. Due to natural conditions, however, erosion and silting cannot be completely avoided. Drainage basin preservation and soil conservation, as well as limitation of improper development, are the approaches that can be considered and are the approaches we can do best. Presently in Taiwan, insofar as preservation and enhancing of a reservoir drainage basin is concerned, the Feitsui Reservoir is more successful than others. The Feitsui Reservoir is the most important water source in the Taipei area. To ensure reservoir water quality and quantity, the government has classified its drainage basin as a designated water source region and established Taipei Water Source Region Management Office to conduct the management. The Taipei Water Source Designated Region is the only designated water source region in Taiwan and is managed by Taipei Water Source Designated Region Management Bureau. The reservoir is managed by Taipei Feitsui Reservoir Management Bureau. The two agencies work together while each assumes its responsibility. The other reservoirs do not have such a setup and must rely on the care of the general public as well as much needed policy support. With the development of the economy, water demand in Taiwan increases continuously, according to the estimate of Water Resources Agency. In 2011, year 100 of the Republic, the total annual water demand shall reach 19.7 billion cubic meters. If one adds 1.5 billion for preservation, plus the use of surface water to replace the 2.28 billion cubic meters which is currently overpumped from groundwater, then the annual water demand shall reach 23.48 billion cubic meters. Considering the current water supply of 18.03 billion cubic meters, the shortage shall reach 5.45 billion cubic meters. Even by promoting water conservation, a gap of about 2.8 billion cubic meters still exists. The above-mentioned gap is computed based on the assumption that agricultural demands for water remain unchanged. With the gradual shrinking of farming, especially after joining the WTO, agricultural water needs should reduce with time, but agricultural water use mostly belongs to that of run-of-the-river water intake. Its reduction in demand does not benefit significantly to public water supply, which has a low tolerance to water shortage. Increasing reservoir storage and regulation capability to store water during wet seasons for use in dry seasons is a means to solve the root cause of the problem. Just how do we increase regulation and storage capability of reservoirs? A lot of people want to build more reservoirs, but this increasing resources approach is currently facing difficulties in Taiwan. In Taiwan, the approach of building reservoirs as a means to increase water resources will encounter the following difficulties. First, there are hydrological uncertainty and limitations on potential usable resources. As stated previously, the water resources utilization rate in Taiwan has reached 30%. Considering the inferior hydrologic condition in Taiwan, it may be said that it will soon reach the upper limit of potential that can be developed. The benefit of constructing reservoirs for intercepting and storing water is not as high as it used to be. Secondly, illegal farming, lumbering, building and burying have increasingly caused surface erosion, landslides, and river pollution. This results in reducing water which can be provided and increasing the cost of water purification. In addition, due to the increasing awareness of the natural habitat, increasing demand of environmental protection, and local participation and involvement of politics, the position of the construction of reservoirs close to people's homes has risen and the resistance has intensified. As a result, it has become exceedingly difficult to acquire the land for project development. It is also difficult to find suitable dam sites. Taiwan now has 40 to 50 reservoirs and had utilized all good topographic and geologic sites suitable for dams. The remaining ones are either too limited in capacity or too high in unit water cost. Therefore, reservoir development is not a long-term solution. Although reservoirs are very important to Taiwan, adopting building new reservoirs as a means for future resources is not a long-lasting and reliable plan. There is a limit to developing new sources, but water saving is an action that we can control. Water saving is not limited to passive reduction of water use. A more aggressive approach is to improve management so as to enhance efficiency of water use and to maximize benefit as a whole by integrating transferring and distribution. The newly completed Chi-Chi Common Diversion Project is a project that through common diversion, integrated distribution, and integrated utilization with groundwater shall maximize the overall benefit of the Shui River water resources as a whole. This shall be the direction of water resources development in Taiwan in the future. Facing the difficulty of possible water shortages, it is the duty of government agencies to improve water resources development and management. Wastewater recycling and the setup of rainwater storage should be first considered. Although the amount of water saved or increased may be limited, through an accumulative effect, the quantity can be large, and by cherishing water resources, the aggressive approach would be rather meaningful. In addition, the cost of seawater desalinization has been reduced because of advancement in technology. The approach may be used for high-yield products. The 21st century is a water era. Water resources problems are critical to determine whether Taiwan can move forward. The problem with Taiwan's water resources is not insufficient, it is uneven distribution. The situation is so severe that it can no longer be ignored. For a sustainable development of Taiwan and for the well-being of future generations, let's love water and care about water. Let's do our best for Taiwan and make Taiwan a truly beautiful Formosa.